Okay, hi all. So I'm gonna show you the key for the quiz of our sections, both two sections for this Tuesday. So each section we have two sample A and B, but they are the same. I just change the order of the choices for the multiple choice question. So we have 30 minutes to complete the quiz. And now we start with the part one. So the part one relates to the proton NMR spectrum. So we have the compound A, and then look at the spectrum. We can see that I give you the number of hydrogen atoms for the each region, and if you are count, and you can see that the total amount of the hydrogen here is equal to the 14. So for the question one, what is the structure of A? And then you look at the region at the aromatic protons, we have the 5 aromatic protons. So we can delete the question D. So these three compounds are ester, right? And if you look at the region of about 4 ppm, you have two hydrogen with a doublet. So two hydrogen is mean that we have the CH2, and doublet it means that it should be next to the one we had one neighboring proton. So in this case, the CH2 should be bound to an electronegative atom, so should be the oxygen. So we can see that we have the choice between B and C. So we have the CH2 bound to the oxygen. So we can choose the choice C. Why we don't choose A and B? If you choose A, this CH2 bound to the carbonyl group. So if you look at the reference, you can see that if you have the CH2 bound to the carbonyl group, it should be shown up in the region about 2 ppm. But what we have here is 4. Should not be the choice A. Well, the choice B, we have the CH next to the oxygen, well, it should be CH2, so we don't choose B. So the question is C. For the question 2, the experimental procedure for the synthesis of A should be found from a cipher. We don't choose the sigma outreach because this um, just give you like the Cas number or the physical properties or the SDS information of the compound. So we don't choose A. Functional groups, even when you cannot choose the correct answer for question 1, you can also answer the question 3. So we can see that both of these compounds, we have the ester group and the aromatic ring, so this should be the ester and arene. For the question 4, so if you count the total number of signals, we have 1, 2, 3, 4, 5, and 6. So we have 6 signals, right? And we have 4 protons in the aromatic region. So we cannot choose. Okay, these 4 compounds have 4 aromatic protons, but you can see that we have 2 doublets. It means that the aromatic compound should have the 2 group in the para position. So if you look at the work in the worksheet lab 1, you can see the one example like this. So we cannot choose B because we have the 2 doublet. It means that we should have the para position. This means that this hydrogen should be like doublet. You cannot choose B because it should be the like the singlet here, right? So we cannot choose B. We don't have the signal of the carboxylic acid. in the region about 10 ppm, so we cannot choose B. So the question here, we can choose A or D. So for this signal, we have the quartet and triplet. If you choose A, you should have the singlet, right? So you cannot choose A. So the question could be D. And you can double check again so that we can have the two triplet here, because this methyl group has the two neighboring protons, and we have the two quartet here because this has three neighboring protons. So we can choose D is the only choice. Even when you cannot choose the right answer, you still have 50% point with question. The part 2 is the questions of the reduction of the ketone. So the question 5 requires you to give the percent yield of this reaction. So first you need to calculate the moles of each compound B and borohydride to see which is the limiting reactant. So for the question 5, so you have the moles of B in the reduction of the ketones. So each carbonyl group should be reduced by one equivalent of the hydride to form the secondary alcohol. But you can see that the moles of the hydride should be start from the borohydride multiplied by 4. So the moles of the hydride we can multiply the moles of the sodium borohydride by 4. Because the reaction is 1:1 ratio, so you can see that B is the limiting reactant in this case. So we can use the moles of B to calculate the theoretical yield of the compound C. So the theoretical yield for the compound C, we can use this mole. We have the molecular weight of compound C is 201.06 gram per mole. And now you can calculate the percent yield of the reaction by, we have the actual yield divided by the theoretical yield. So the yield percent should be 33.4%. So the choice should be C. I can see that the question 6 is like a little bit complex, but if you know how to use the dimensional analysis, you can solve the question 6. So it requires you to give the cost to prepare 10 grams of compound C. So the cost, total of cost So we can use for the 10 gram of C, we multiply by the total of the price of the starting material for 1 gram of C. So if you can know the price for 1 gram of C, you can multiply by 10 gram of C, you can have the total cost for 10 gram of C in this case. So the cost of the starting material include the cost for compound B, sodium borohydride, and the methanol, which is used as a solvent. So we have the first we calculate the cost for the from the compound B, right? So we can see that for the compound B, $4 for each 25 grams of B. And then you can use the data from the question 5 that we have the 2.5 gram of B for each 2.11 gram of C. And then if you can remove the gram B, you can have the gram C at the bottom, right? And then you plus the dollar for the sodium borohydride. So we have the $65 for 100 gram of sodium borohydride and 0.21 gram of borohydride for 2.11 gram of C. And then we plus the dollar for the methanol, which is the solvent used in the reaction. So it is $47 for 1,000 millimeter. But we use the only 50 millimeter for 2.11 gram C. And then you use the calculator. We can remove the gram B, gram borohydride, millimeter of methanol, and we also remove the gram C here. So we only keep the dollar, which is the cost of the starting material. So the value is a 13.68. So it's round to the nearest number is $14. So the choice is B. For the true-false question, you can see that there are 3 signals expected in the proton spectrum of B. So from the compound B, we have the methyl proton, this aromatic proton, and this. But because we have the symmetry here, so we only have 1, 2, and 3 signals. These 2 protons are similar, and these 2 protons are similar. So we have 3 signals. So this should be true. For the protonium spectrum of C, the methyl protons exhibit a triplet. So for the compound C, since the methyl proton only have 1 neighboring proton, so it should be a duplet. It shouldn't triplet, so it should be false. The conversion of C to B in another reaction is an oxidation. So from C to B, we have discussed this problem in class. So from C to B, we increase the bond between the C and O. So if the process increase the bond between carbon and an electronegative atom like oxygen and nitrogen, this could be the oxidation. So this is true. 1 mole of B is reduced by at least 4 moles of sodium borohydride. It is false because only 1 hydride is used for 1 mole of ketone. So because we have the 1 mole hydride, so the moles of sodium borohydride should be 1/4. moles. It's not for moles, so it should be false. For the last statement, the compounds B and C are indistinguishable by or it is false. Why? Because compound B is a ketone. It has the carbonyl group. It should be show up in the region about 1700 in the IR spectrum. While this is the alcohol, so the group IR signal should be about like 3300. So we can differentiate them in using the IR. So this statement is false. So if you answer, we have 5 correct answer, you can have the 10 points for this question. For the question 8, I can see many students, they write the whole mechanism for this question, so they only have like 8 points per 10. Why? Because they only requires to write the curve area mechanism for only 3 steps. So you can see that 2 steps resulting in nucleic substitution followed by a proton transfer step. You can start from the first step, like the deprotonation of the ketone to form the enolate, and use this enolate attack the HOCl, which is the electrophile, via the SN2 pathway. So it could be the nucleophilic substitution, and then we use the chlorinated ketone and being deprotonated by a base. So you can write these 3 steps, but you can also write the step at the very late stage, like when we have the trichloroketone, we can let it attack by the hydroxide anion and to form the intermediate, and then break down the intermediate via the E2 pathway to form the carboxylic acid and the trichloroanion. So I will draw these steps. So when you have the trichloroketone, and we make the nucleophilic addition of this hydroxide, and then we collapse this intermediate via the E2 pathway. The last step should be irreversible because this should be a acid-base reaction, and this is the base will deprotonate this proton. So we form the carboxylate, salt, and chloroform. So we have the 3 steps. We have these 2 steps resulting in the nucleophilic substitution. Why? We have the substitution of this group by the OH group here. So this combination gives you the nucleophilic substitution, and the last step is the proton transfer to form the benzoate and the chloroform. So based on the reaction mechanism, it means that you base on the whole mechanism in your note card, not this mechanism, right? Because this just the part of the mechanism, is not the whole reaction mechanism. So if you look at the reaction mechanism, you will see that the electrophile should be this compound, And you can see that this compound should be electrified because we have the nucleophilic attack of this hydroxide to this carbonyl. So you should write these two compounds. For the other compounds, I can see that it's just the acid-base reaction, right? So acidic protons are not considered in this question. So if some students, they choose the compound intermediates from to produce the enolate, and they use that like the electrify. And this question we don't count the acidic protons, so we only have these compounds and this compound, right? And we circle the electrophilic center. So in this case, when you form the enolate and you attack that enolate to this compound via the SN2, so this should be the electrify, and the chlorine is the electrophilic center because it accepts the lone pair or the pair, the negative charge of the enolate, right? So this should be the electrophilic center, while this compound, we have this carbon, it is carbonyl group, should be the electrophilic center. So we have these two cases. For the question 10, we have two work. First, you need to say yes or no. It is possible, it is impossible. So in this case, because the vacuum filtration is used to separate the solid from the liquid, right? So we cannot use it before the acidification. Why? Because when you end up the reaction, you obtain the water-soluble salt. It is the water-soluble salt. It means that we don't have any solid when you finish the reaction. So because we don't have solids, so that we cannot use the vacuum filtration before the acidification. When you make the acidification of this salt, you will form the benzoic acid, which is insoluble, right? And now we answer this is no, because this technique only used for the solid which could only obtain after the acidification. You can say like that. Okay, so for the last bonus point, I will give you the solution. The compound D exhibit one singlet in its proton NMR spectrum, but shows no IR peaks. About 33 red means that it doesn't have the OH group. And this also doesn't have the carbonyl group, right? Because no peak in the region about 17 red is show up. So if you calculate the degree of unsaturation of this compound, you will see that it has the unsaturation number is 1. This means that it should have one ring or one pi bond. The pi bond here is mean that we can have the C double bond to C or C double bond to O, since we only have CH and O. But we don't have the C double bond to O, so it means that we don't have the CO here. We don't have the hydroxy group. So in this case, we only have the ring. We have only one singlet. It means that this proton should be equivalent. It doesn't have the different neighboring protons around itself. And in the protonic NMR spectrum is about 3.71. It means that it should be in this region. So the proton should be attached to the carbon bearing the electronegative atom. In this case, we have the oxygen. So in this case, we have this is the structure for this question. You can see that we have the 4 CH2, but these 4 CH2 protons, they are similar or chemical equivalent, so that's the reason why they have only shown the one singlet. And this methylene group attached to the oxygen, which is the electronegative atom, so that's the reason why it show up in the region about 4 ppm. Okay, so we finished.